usage, IP address is used whenever a device wants to join a network. Like we are living on the earth, okay? So we
Yeah.
have names. If we find a person without having any name,
No.
we will never find a person without having a name. So if someone wants to interact on the earth, he should have a name. A human being must have a name. So with the name, we can differentiate the human beings. Same thing in the internet. Whenever a device wants to join the network, he must be provided with a unique identifier, that is the IP address.
Okay.
This IP address is given by the Internet Protocol. This is the Internet Protocol way of identifying addressing. That's why we call IP address. If it was a IPX, then we used to call IPX address. Okay, but mostly everyone uses the IP addresses, so we are working with the IP address. Okay. So IP address is an address used in order to uniquely identify a device on an IP network. It was developed in the early 1980s. Okay. So it is managed by the IA and Internet Assigned Numbers Authority. These guys will manage the IP address. So now maybe you have heard about IPv6. Yes, have you heard anything about IPv6?
Yes, sir.
Okay.
It's,
So normally the one which we are using and which we were using for many years, it is IPv4.
yes.
But the latest means almost many years back, they introduced IPv6 also. Because at IPv4, at the time of IPv4, that was a beginning era of the internet. At that time, we don't have any device like laptops. At that time, there were no Facebook, nothing, no internet websites were there. There were not many mobile. There were no nothing like mobile phones. So very few users were there. So at that time, they thought that what should be the range of IP address. Just can you kindly mute your mic? Okay. Whenever it is needed, if you want, whenever you want to ask the question, you can turn it on. Okay.
Myself, sir.
Yeah, your side. You're already
Okay.
giving some voices. Maybe you are at the roadside something, no?
No, no, sir. I'm at home only.
रूम के बाहर रोड है शायद, तो ये माइक
Okay.
में क्या होता, रोड
Okay.
के वॉइसेस भी आ जाते हैं इसमें.
Uh,
Okay. So whenever you want to ask a question, you can turn it on. Okay.
yes, sir. I'm meeting.
Okay.
Yes, sir.
So at the time of creating of the IP addresses, they have to identify what should be the scope of addresses. How many addresses we need so that many persons can join the network. So at that time they have identified, okay, maybe if we need 32-bit addressing, means we need 2 power 32 addresses, that will be more than enough for us. 2 power 32 means some billions and billions of addresses. But what happened now in the 1996, they realized that maybe in future will come shortage of IP addresses. Shortage means we will not have enough available IP addresses so that a new person can join, a new device can join a network. So this was realized in the 1996 at that period only. So they started testing, they started developing, thinking about different mechanism, and they came up with one of the mechanism providing the new IP addressing, that is the IPv6. So because we are coming shortage of IP addresses, we came up with the IPv6. So previously in the IPv4 it was 32-bit addressing. Now in the IPv6 it is 128-bit addressing. The difference is the number of addresses. In 32-bit addressing you used to get some billions of addresses. In 128, 2 power 128 means a very big huge number. So it is predicted that almost 2000 years we will never come shortage of IPv6 address. The prediction is that Don't think that okay, maybe after a decade you will get IPv7. Nothing like that. Maybe after 2000 years you may get a shortage, not now. Okay. So now the other thing is that IPv4 is of 32 bits. These 32 bits is divided into some partitions. Each partitions contains 8 bits, which we call it as a octet. Total 4 partitions will be there. We will see now in detail. And how we are going to write dotted decimal format will be the IPv4 addressing. So now we'll start with the complete IPv4. Once we are done with the some protocols, then we will talk about the IPv6. Means almost after 15 to 10 after 10 classes maybe, we'll come across to the IPv6. We'll start with the IPv4. We'll see in detail about the IPv4. Okay. So now from here, everything is very, very important. Okay. So without IP addressing basic foundation, you cannot understand the networking concepts. So now what he is saying here, what I said just now, I said that IPv4 address is of how many bits? 32 bits. So you can count here. So this is the first bit. So first, second, third, like that, total 32 bits are there. Okay. And I said that these 32 bits are divided into the 4 octets. Okay. So if you see here, these are your 4 octets. This is the octet. Octet means a group of 8 bits. This is one octet. This is the other octet, 8 bits. So total 4 octets will be there in the IPv4 addressing. And each octet contains 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits, 8 bits, 8 bits, 8 bits. 4 times 8, it is 32. So total 32 bits addressing. And we know IP address will be in the binary. Binary means you will have 2 options, 0 and 1, 2 digits only, 0 and 1. So in binary, every bit will have a place value. Like this one, the first bit will be 2 power 0, this will be 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. 2 power 0 is 1, 2, 4, 8, 16, 32, 64, 128. So every bit will have a place values. The first bit is 0, 0 value is 1. Second is 2 for this octet. So this octet is the first octet. This octet is referred as second octet. This one as the third octet, and this one as the fourth octet. So fourth octet, first bit value is 1, second bit 2. Like this, every octet will start from 1 and it will end by 128, because 2 power minimum value of an octet is 2 power 0 and maximum value is 2 power 7. You cannot have an octet with the value 2 power 8. We will stop at 2 power 7, that is 128. So we will start at 1 and you will stop at 128. Okay. So till here, any question?
Sir, here
Yes.
for 32 bit means there are 4 octets. So in each 8 bits is
So for what I did here, see here, these all are 32 bits only, 0, 0, 0. This total are 32. These 32 are divided into the octet. Octet means a group of 8 bits. So this is the first group of 8 bits. This is the first octet. Okay. This is the second octet. Group of 8 bits is known as octet. This is the third octet. This is the fourth octet. Okay. Any other doubt?
No, this is blindly we need to remember as
Yes, simple thing. Complete IPv4 will be of 32 bits. These 32 bits are divided into 4 octets, and each octet will be of 8 bits. That's it. We should remember these things.
Okay, sir.
Okay. And every bit value will start with the power of 2, 2 power 0, 2 power 1, like this. So every octet will start with the 1 and it will end at 128. Okay. So any idea about the binary conversion, like decimal to binary? For example, you can see here, we know in the binary there will be 2 bits only, 0 and 1. 0 represents that this place value you are not utilizing. It is turned off. One represents that this place value will be utilized. Okay, this let's see how this will make sense. Now normally we remember the IP address. Mostly you have seen the IP address will be 192.168.1.2 like this. So this is the first octet, this is second octet, third octet, and fourth octet. You may have seen the IP address like 10.1.2, same thing, 4 octets, and each octet contains 8 bits. But we are not writing total 32 bits. We will convert into a decimal, and because binary we cannot remember. If I ask you remember 32 bits, you cannot remember those 32 bits. So we convert into a decimal and we remember into a decimal format. So as a network engineer, you need to know how to convert decimal into the binary. Okay. For example, I have taken one example here that I want to write 192.168.1.10 in binary. Okay. So we know that every octet will have 8 bits. So I am writing those 8 bits value will be what? First value will be 128 2 power 7, then 64 2 power 6, 2 power 5 is 32, 2 power 6 is 2 power 4 is 16, 3 is 8, 4, 2, 1. So you can see first bit, second, third, fourth, fifth, sixth, seventh, 8 bits. Now I want to write 192. Okay, I want to convert decimal value 192 into the binary value. So in binary, 0 means you are not using the place value, it is turned off. 1 means it is on. So now in order to make 192, how many values I need to use? 192 means I need to use 128 and 64. The 128 plus 64 will become 192. Remaining bits I need not to use, so I am going to make them as 0. So you have different methods also. Normally maybe you are aware of this method, like 192 means you will write 20 something, कुछ ज़्यादा,
Yeah.
वो
Yeah.
method. So you can use this method, easy one. So like 168 means I need to use 128, 64 no need, 32 128 plus 32 160, 160 plus 16 0, 8 0 0 0. Similarly, 1 means only one value I need to use, so remaining all the values will be the 0. And 10 means what will be the 10?
8 and 2.
8 and 2. So means the remaining 128, 64, 32, 16, 8, 2, remaining will be 0. Okay.
Okay.
So this is how you are going to convert to binary. But we remember, normally we remember the addresses like this. But if you want to, in the IP addressing, we need to know how to convert by decimal to the binary. Okay.
Okay. Okay.
Now, so 128 is there, 64 is there, 32, 16, 8, 4, 2, 1. If I don't use any bit, if all the bits are 0, what will be the value?
None.
0 it will be. Okay. If I
Yeah.
turn on all the bits, if I utilize all the bits, 128, 64, 32, 16, 8, 4, 2, 1, then
1.
I'm using all the bits. No, all the bits are turned on. Then what will be the value?
I mean, we need
You
to
need
add
to add
20.
all 128
Yeah.
plus 4, 192, 192 plus 32, 224, 224 plus 16, 240, 240 plus 8, 248, 248 plus 4, 252, 252 plus 2, 254 plus 1, 255. Okay. So maximum value, this value will be how much? All bits if you turn on 255.
254. Okay.
So by this one, I can conclude that for every octet, minimum value will be 0. If I write all 8 bits 0, then the value will be 0. And for every octet, if I turn on all the bits, all 8 bits for every octet, then the value will be how much? 255. Okay. So it means the range of the complete IPv4 is 0.0.0 till 255.255.255. It means you will never see a address which is less than 0, -1, -2 like that, or you will never see an address which is greater than 255 like 257, 258. You will never see like that. Okay. So we have started with the IPv4. IPv4 contains 32 bits. 32 bits are divided into 4 octets. Each octet is a combination of 8 bits. Okay, and we have seen how to convert the decimal to the binary, and from this we are able to identify that with the help of 32 bits we can get the addresses from 0.0.0 till 255.255.255. Okay, so it means like your addresses, first address will be 0.0.0, then the next address will be 0.0.1, then it will be 0.0.2, then this octet whenever it becomes 255, can I write 256 with the help of 8 bits?
No.
So what at that time what we do, we will convert this position to 1. Okay, because in binary 8 bits concept you cannot have more than 255. So if you want to write 256, it means you will write like this 1.0. Okay, then the next address will be 1.1, 1.2, 1.3, and this also whenever it becomes 1.255, can I write 1.256?
No, sir.
So the next address will be 0.0.2.0.
Yeah.
Okay. So whenever it is 255, you are writing 1255, then 1.0, or you are adding up 1. Okay. So plus 1 you are doing. Okay. Plus 1. So you also already it was 1. So if you add plus 1, it will be 2. Okay, so like this whenever this octet changes to 255, this will go on converting. Whenever this becomes 255, it will be changed to 1. So it may be like this 1.0.0, then you will start with 1.0.1. Whenever this is changed to 255, all 255, then you will change this one. Okay. So like this, all the octet value will be changed. So the first value will be 00, and the last value will be all 255s. So if you want to count how many are this, then you need to know the value of 2 power 32. Whatever that 2 power 32 value is there, those are the values which are starting from here. These are the number of values ending at here.
Okay.
So all these are the IP address. Whenever a device wants to join a network, we use these addresses. Okay, but some addresses are reserved. You cannot use 0, anything starting from 0. Those things we'll see later on. Okay. Any doubt till here?
No, sir.
Okay. So now your complete range is, we have got the information 0.0.0 till 255.255. Now, for example, you got some 100 acres of land. Okay. And you want to sell it. For example, this is your 100 acres of land and you want to sell it. A person came and is asking, give me some 20 acres. Imagine from here you have given him some 20 acres. Other person came, he is asking, give me some 30 acres. From here you have given some 30 acres. Okay. Now some other person came and he is asking, give me 50 acres. You have given 20 here, 30 here. Now remaining someone wants to give. Can you give him, okay, can you say, okay, take some from here, then take some from here, then take like this. Will he agree on your, if you say like this, will he agree?
No,
No.
small.
Because what is happening here, wastage is happening now. Because no one will take like that. Okay. So no one will first of all sell like this. What you will do now, whenever you want to sell 100 acres, you will do a plotting. You will reserve, okay, for some person coming from industry, I will use this. From the medium industries, I will use this. From the house purposes, homes, small homes, I will use this. You will do the plotting. You will make like, okay, this is for the bigger companies, this is for the medium, this is for the small, like this small requirement. Okay, so someone comes for that 30%, you will give from here or here. Some less than, someone is asking 15%, you will give from here. Someone is asking 5%, you will give from here, so that there will be no wastage of the land or anything. Okay, so if you do the proper plotting, then that is the benefit. You will not waste anything. So same thing in the IPv4, you have the complete range is there. This range is for this range of IP addresses is going to be used for anyone whoever wants to join the network. So this purpose, maybe some organization will be from bigger companies. They want some millions of addresses, some want some thousands of addresses, some want some tens of addresses, very less IP addresses. So based upon this requirement, what they did, they have divided this IP address complete range into some 5 classes. The complete IP address range is divided into 5 classes. We call them as a class A, B, C, D, and E. Okay. 5 classes are divided. Just to give the range that these IPs are for bigger organization, millions IPs, thousands for medium, hundreds like that. Okay. So class A, B, C, these are the ranges I will show up here. These are the range of class A. Class A will start from 0.0.0. It will end at 127. Class B 128. It will end at 191. Class C 192. A starting point and ends at 223. Similarly, class D and class E. Class A, you need to remember these ranges. Okay, class A will start from 0.0.0 127. Suppose if I am asking what is your IP is starting from 10. So it means in which class it will be? It is from which class?
It is A class.
And if my IP address is starting from 200, then
C.
yes, it will be from C. Okay. So now what happened here? You have 3 ways of communication. Okay. If you want to make communication between some devices, you have 3 methods. One of the method is known as unicast. Any idea about unicast?
No, sir.
Now we are in one session where only 2 devices are communicating. Over a network, only 2 devices are communicating, no other device is making the communication here. Communication between 2 devices is known as unicast. Okay. Now I am in the unicast session, I am directly teaching to you. The next one is the multicast. Imagine I am teaching in a class. I have a classroom in that many students are there. Many means imagine 10 to 15 or whatever. Group means limited number of members. Something like 1 candidate here, 2. Maybe I am having many, but I am teaching to only a group of people, not everyone. So I am sending information only to a group of people. Then this is known as multicast. 1 to a group. This is 1-to-1 communication. Unicast is 1-to-1. Multicast is 1 to a group. A group means limited. Okay. If you want to send the data to everyone, irrespective whether he wants to listen your information or not, but you want to send the data to everyone, that is known as broadcast. In the broadcast, the unnecessary data will be forwarded to everyone. You are getting disturbed and making disturb to everyone. Something like on a junction, I am teaching. So if I'm sitting on a junction and I teach, maybe a person who needed networking knowledge, he will stand and listen. But the other guys will scold me because they will first listen, they will come to know networking and they are not interested. They will say that you are wasting our time. So if you want to make communication in a network, you have three options. You can either go with the unicast way of communication. In the unicast way of communication, only two devices will participate. But you want to send some information to a group of devices, then you will go with the multicast, where one information will be forwarded to a group of members. Group means always limited. But if you want to send the information to everyone, that is known as the broadcast. Okay. Any doubt in this unicast, multicast, and broadcast?
No, sir. I'm good.
Okay. So now what happened? The IANA said that if you want to assign a IP address, which may be in your LAN network or WAN network or any way, but you want to assign an IP address, then you should use the IP address from class A, B, C range only. You can use the addresses from these classes only. Okay, because the class D is reserved for the special purpose like multicast. Okay, now imagine you want to stream a video, okay, live video, but you want to stream it to the persons who have already paid for that video. All over the world, maybe 100 customers are there. So what we will do, you will first gather the information about those 100 customers. Over the network, your information will be forwarded only to those customers, multicasting. So how to implement, you will see in the higher studies what is multicast, how it will be configured. A basics of that one in the routing protocols we will learn. So for that, a group also, suppose since I said 100 customers are for your video, to identify those customers, you will use a group number from this range. Something like maybe you will say my group number is 239.1.1. Means this group number will be assigned to your 100 customers. So whenever you want to send any broadcast any video, you want to stream a video, you will stream on this address. Okay, now this address means it is for your all the 100 customers. The information will go to all your customers. So this address which you are going to select, you are going to select from the special class which is reserved for your job, that is the class D. So whenever you want to assign a specific address for multicasting, you will select the address from only the class D. There is no other option. Okay? So it is reserved for multicasting purpose. For research and develop purpose, class E is reserved. Okay, so it means whenever you want to assign an IP address in a network on a device, you can use this address from class A, B, C only. You cannot use from class D and E. Okay.
Okay. So companies also, these addresses will be there only. I
Only
see.
ABC. Check any
Yeah.
PC, check any laptop, only ABC will be there. But high
Yeah.
level, if you go to routing protocols concept, multicasting concept, there they will use the addresses, multicast address.
Okay.
Okay. Normally, you cannot see that address on a PC. You will see on the configuration on the routers. Okay.
Yeah. And
It is a
E
group
also.
address. Yes. E is
And E.
research and development. The scientists, you will never see those one. Those are reserved for the research and development or future purpose. You will never use. You will never use these addresses. Okay.
Yeah.
Now, imagine your door number. I want to send some courier. Okay. Or you ordered a courier. Okay. Whenever you order a courier, the courier guy will ask you the address. Then what you will do, you will give him the address information. Like you will say your door number is something like 10-5-750. You will give this door number. Okay. So now what information this courier guy can get from this door number? Is it a meaningful information or just a random information you have provided to him?
No, this is not complete address.
No, normally just leave the lane number, all those things. Imagine that in our now in India, imagine that okay, we are running the three address where 10 will give the locality, then 5 will give the lane address, then 750 will give the door number. Okay. So all these three things are needed if someone wants to deliver anything to your address. Okay. If the courier guy is saying that give me address, you are saying that okay, my address is 10-5. So can he come to your home directly now?
No.
No, he cannot come. If you say just okay, my address is 750, can he come to your home?
No.
So imagine you are complete, for example, the Hyderabad is a location. In this location, you have divided into multiple areas. Every area, that is locality, will have a name, right? Okay, in this locality you may find door number 10, and in this locality also you will find a door number 10, but both are different because that locality maybe it is 10-5-10 and your locality may be 10-7-10. So this 10 and this 10 doesn't belong to the same location, they belong to different locations. Yes.
Yes.
So it means in the complete region, you will have multiple localities, and every locality will have set of door numbers. Okay. So why we are having all this is to get delivered the information from one place to the other concerned person only without any headache. Yes. Same thing, you will get the information in the IP address also, because IP address is also a way of communication only, where you are giving the names so that devices wants to communicate with each other. So whenever I am saying a IP, the IP will give me meaningful information. The locality is known as here network, and your door numbers are known as here host. Okay. So host means a computer or any member of a network. Like you have, I said, you have a local region. In this region, you have many locations. Every location will have multiple door numbers. So these door numbers, which are multiple in a location, are the host. Okay, it is like your door number. Okay. Host means door number, and network means your street name, locality name. Okay. So IP address gives two informations, network information as well as the host information. Network will identify the network portion of the IP address will identify that which network you belong. Suppose someone called me and is asking that what is your IP? I said my IP is 5.5, 50.1.1.10. And I asked him what is your IP. He's saying that my IP is something like 50.1.1.12. Okay. So imagine this first portion identifies the network. Here also the first portion identifies the network. Remaining portions will identify the host. So can you let me know whether we both belong to the same network or different network?
No, same network.
We belong to the same network because the network portion is matching. Okay. So in a IP address, some information will be network information and some information will be host information, by which only we can identify whether both the devices belongs to the same network or different network. So network bit means a set of information which will identify which network you belong. Okay. Host means a member of a network. So same thing here in the IP addressing here. What is a network? Is collection of multiple hosts, a group of devices. We call it as a network, and every network will have many devices. An individual device we call it as a host. One of the individual node means device is known as a host. So now class A is for bigger companies. Class B is for medium organization, which doesn't require high range of addresses, high number of addresses or low numbers. Class C is with the low. So A is for the bigger companies, means I want to get here millions of addresses. A network should contain millions of addresses. Here I want each network should contain thousands of addresses. And here I want each network should contain some hundreds of IPs. So which one should be having more IPs? The A. So if a class A is created specially for a high level customers, we require more number of IP address, then it means I need to give them host bits many. Okay, so now it is very important to understand this. I have a locality. Okay, maybe in this region some 10,000 peoples are living. 10,000 homes are there. So now this complete locality I am dividing into three regions on complete 10,000. So now this 10,000 is divided by 3, means every region will get minimum 3,000 addresses, 3,000 doors. Okay. Now same thing, I have one more region where I am having 10,000 IPs, but here I am dividing this complete region into the some 6 localities. So what happens, 10,000 divided by 6? So everyone will get how many addresses? Very less, maybe one. कितना था 6 से divide किया तो 6
1600.
some 1.5 for example, means 1.5 thousand addresses. Means what I mean to say here, that if you have more localities, automatically door numbers will be decreased. Number of, means if you see here in this the left hand, every locality is having 3,000 doors, because only 3 regions are there, 3 localities are there. Here you have many localities, so automatically every locality will have less number of doors. You got my point, what I mean to say?
Yes, sir.
Yeah. Just I mean to say that if you have more locations, you will get less door numbers. If you have less locations, then you will get more door numbers. So just everything is just to make you understand what is this class A. Okay. So in the
Yes, sir.
class A, this is for the bigger companies which require millions of IPs. So millions of IPs you require means you need to have less regions. Okay. So what I did for class A, we have provided only one octet as network octet, but many octets as host. Because of this, you will get some 16 million IP addresses. How we will get, we'll see those calculations, but just I'm saying that class A is especially for bigger companies, that's why we have allocated only one network octet. Class B is for medium, means I want to reduce the number of hosts. If you want to reduce the number of hosts, increase the number of networks. So here we got only 2 network octets, here one network octet, here we got one more network octet. Because of this, the number of IPs will be reduced and it will be in thousands. Similarly, class C, I want for a very small organization, means host octet should be less. I need to increase the regions. So I have increased the regions network portion. Okay. Class A, this is by default EVM. Okay, these are all of the default information. Okay, later on we'll see how in the advanced classes how to change default information. Also, we will see what is subnetting. Okay, but first we should understand these basics. Then only we can understand subnetting. Okay. And this is a default information. Okay, so class A will have only one network octet and 3 host octet, because this is for bigger companies where they require many IP addresses. Class B is for 2 network octets, and sorry, class B is for medium level, so we have increased the number of network. Previously it was 1, here we are giving 2 networks. Class C is for very small organization, so we increase the more number of network bits and we decrease the host. So how this will be affecting in detail, I will show you now. For example, very important now, these 3-4 slides. If you have any doubt, you can stop me.
Yes, sir.
Now here, I will start with the first example, class A example. Okay. In the class A, what is the range of class A? Class A will start from 0.0.0.0 and it will end at 127.255.255.255. Okay. So as I just now shown to you, class A will have one network octet and remaining will be the host octet. Okay. Now our job is to know if one network octet I am getting, how many localities can I get? How many networks I can have? You should remember the range. Range starts from 0, 1, 2, 3, 4 up to 127. So your first network will be 0.0.0. Your second network will be 1.0.0. I'm just writing about network portion. So I'm just changing only the network end. I am not doing anything to the host. So second network will be 1.0.0, third will be 2.0.0, fourth will be 3.0.0. What will be the last network? Where should I stop?
127.
127. Why should stop 127? Means the 127 is the end point of the class A. So now all these are the door numbers or the localities.
Door numbers and localities.
These are the networks or the host.
A network.
Yes. So remember, these are the class A networks. How many networks are there here?
127.
0 to 127 means total 128.
Yeah.
Okay. So this is one location name. Okay. Like Silk Board, one location name. HSR layout, one location name. So these are the location name. Now I want to know in each location how many IP addresses we are going to get. Okay. So I will take one of the location. I will select 2 dots. You can select anything. I'm going with this one, for example, 2.0.0. So we know that 2.0.0 is from class A. So I am writing network host, and now this network I want to know how many IPs I will get. Means from this specific locality means this will not change now, it will remain constant, but these values will go on changing because I want to write each door number from this network. Okay, I want to write the door number from each of these networks. So now for what will be the first address? The first IP will be the 2.0.0.1. We will always, whenever you are writing the IP, you will start from the last octet, fourth octet. Then the next will be 0.2. Then I will stop at 2.0.255 because I cannot write 255. But you can see the next portion is the host. This is the second one is the host. So what can I do? I can increment 1 here because it is the host. I can change. Then I can write 2.0.1.1. Whenever this becomes 255, it will get changed. Whenever this becomes 255, it will change. So at the end, I will be stopping at 2.255.255.255. Because after 255, if I increase, it will become 3. And our network is 2. We cannot write 3 here. Okay. So our last IP address will be 2.255.255.255. The first address is 2.0.0, the next one is 2.0.1. So I am making these two constant because this is the first octet is the network, and I am writing everything about a network 2.0.0. Okay, this network 2.0.0 will contain these many hosts. Okay. So every network, whatever we are writing in the left side, it is a network information. So you have 128 networks. So take any network, every network will start from 2. Suppose one of the network may be 100.0.0. So I will write for that one also. So 100.0.0, then 100.0.0.1. Whenever this becomes 255, this becomes 1.0. Whenever this becomes 255, and this will be also become 255, then it will be 100.1.0. Whenever this changes, this also changes, this also changes. At the end, it will be 100.255.255.255. So all these are the IP addresses which belongs to this network. Here also all these are the hosts. Host of which network? Host of 2.0.0 network. All these are the hosts of the 2.0.0 network. Okay. Here all these are the hosts of the network 100.0.0. Any doubts till here?
Yeah. Yes, sir.
Okay. Now we have some technical words here. For example, for every network, the first IP, we call it as a network ID. The first IP address of a network is known as the name of the network. This will represent the name. Like for your company, you have a name. So all the employees, if you ask any employee, okay, which company you belong, you will give the name of your company. Same thing for all these IPs, which network you belong, they will say 2 network, 2.0.0. Similarly, for this 100 network, this will be the network ID. Okay, for the 100 network. Every network first name is a network ID and the last name is known as the broadcast ID. Network ID is an identifier value for your network. If you are someone is asking where you live, you will give this name. Okay, I belong to a network 50.0.0. I belong to a network 192.168.1.0. Like this, you will give the network names. But what is the usage of broadcast ID? If any one of this member from this entire range, any one of the member wants to send data to all the other members of the same network, then you are going to use the broadcast ID. Whenever suppose 2.0 a person sitting on the PC 2.0.2 wants to send a message like happy Diwali to all the other members on the same network, just he will write a message on this address, the broadcast address. Once he delivers anything on this address, it means it will be delivered to all the members of the network. Okay, that is a group broadcasting address. Your network's broadcasting address. The first address is the name of the network. So that is used for reference. Whenever someone asks for which network you belong, you say I belong to 2.0.0. But broadcast ID to send the information to everyone. So these two IPs are for special purpose. So this cannot be given to a single person. You cannot say your friend, okay, what's your name? He cannot say my name is Cisco. Cisco is a company name. Okay, so that cannot be given to an individual person. Same thing, network ID is a reference name. It cannot be given to an individual computer. You cannot go to your computer settings and you cannot configure the network name as a normal IP. Your PC will say this is not a valid IP. Okay. And similarly, broadcast address is not for just one person. It is for a group of people communication special purpose. So this address can also be not configured or not given to any individual persons. So these two addresses are reserved. No one can use on their devices, on their computers and devices. So whenever someone asks you how many IP, that give me 30 IPs, 50 IPs, while calculating, you will delete these two IPs. You will never calculate these two IPs. You will say, okay, you want 30 IPs, then I have to go with that 32 IPs because two IPs will never be counted, broadcast ID and network ID. Okay. So whenever you are giving, suppose you have 100 computers and you want to ask the ISP that give me 100 IPs. So you will not say 100 IPs. You will say one or two IPs. Because at the end of the day, two IPs will be wasted. You cannot use to any device, but they will be used for the special purpose. Take any network.
Normally,
Yes.
sir, normally we can use this one, right? 2.0.0. The
Yeah,
keyword.
ISP said no. Normally we cannot use. We can use locally in our network, but if you want to communicate from one location to the other locations, you cannot use. You need to purchase the IPs from the ISPs. Whatever the IPs you have purchased from the ISP, those IPs can only you can use. Okay.
Okay.
So the conclusion is that class A has 128 networks, and we have seen that every network will start, for example, network 2 starts from 2.0.0, which is known as the network ID. And whenever it becomes the last octet becomes 255, the next octet, since it is a host portion, it will be converted. And we'll stop here because after 255 in the third octet, if I try to convert it, this is not a host portion, this is a network portion cannot be converted while calculating host, so we'll stop here. And the first IP is known as network ID, last is broadcast ID. In between them, whatever the remaining IPs are there, we call them as the valid IPs, which can be used. Network ID cannot be configured to any other device, and broadcast ID also. These are not valid IPs. Valid IPs are the IPs which are between the network and the broadcast. So here in the class A, can you tell me how many valid IPs we'll get?
One 125.
How? You can see 1, 2, here only 255 over. Then
Okay.
1, 2, many are
Uh,
there.
uh, no, I am thinking from here network.
Hmm.
Sorry.
Total number of hosts. If you want to calculate, total number of hosts is equal to 2 power host bits minus 2. Minus 2 because network ID and broadcast ID will not be calculated. So now how many are the host bits here? In class A,
Three.
3 bits are 3 octets.
Three
These are
octets.
3 octets. 3 octet means how many bits? 24 bits.
Two.
Okay. So 2 power 24 minus 2, it will be approximately 16.7 million. Okay. So if you have a requirement of millions of IPs, then you will purchase from the class A. ISP will provide you the addresses from the class A. Okay. So the calculation formula is very, very important. Take a snapshot or screenshot of this slide.
Okay, sir. Hold on. One second, sir.
Okay.
Yes, sir.
Okay. I'm getting messages now. So now let's go for the other class, class B addresses. Class B, how many network portions and host portions in class B?
Two network host
Yes.
and two
And the
hosts.
range starts from 128.0.0 and it will end at 191.255.255. Okay. So class B has 2 network octets and 2 host octets. Okay. So what will be my first network?
128.
128. 128.0.0 will be the first network. What will be the second network?
127. No,
127.
129. 129,
No,
sorry.
not 129. It will not be 129. Just a second. Think it will not be 129. It was class A. That's why It was after 1, it was 2,
Zero.
like that. Okay. But now this is not class A, this is class B. You are saying that you have 2 octets. Yes.
Yeah.
So what will be the next one?
Not 191, right?
Yeah, then what it will be? See here, these are very important things, very small. As a beginner, these are important, but once you get habituated, it will be very easy. It should not be a problem. So the first network address will be 128.0.0. Okay, but the second one, next one, see here, this is two networks. Previously, it was one network and 3 hosts. So I started 0.0.0. The second one was not network, it was host. So I jumped to 1.0.0, then 2.0.0. Okay, because it was having only one network. Okay, but here the case is little bit different. You have two networks. So after writing 128.0, the next one will be 128.1. Okay, everything is changed because of the number of networks we are using. Okay, so then the next one will be 128.2.0.0. Whenever this becomes 255, then you will get one more network because you have two network octets. You will get 129.0. All these are the networks only. So you will get many networks in the class B because you have 16 network bits, 2 octets. Okay. So the last network, this becomes 255, then it will be changed. The last network will be 191.255.0.0. Okay. So in class A, you have got 0 till 127. Means total 128 networks in class A. But in class B, since you got two network octets, you are getting many. You will get 16,384 networks. Yes, understood this point?
Yes, sir.
Yeah. Networks are many because you are getting many networks because you have two network octets. So everything is dependent upon how many network bits and how many host bits, how many network octets and how many host octets. One network octet, only 128 networks. Two network octets, you are getting many, 16,384 networks. Okay. Then like previously, one of the network we have seen that how many IPs it will get. Now let's check that one. I want to know. So out of all these networks, class B, which one is your favorite network? Which one you want to see the number of hosts? कौन सा select करना चाह रहे हैं? Let's take the 128.2.0.0. Yeah. Now I want to know from this network from 128.2.0.0, I want to know how many IPs I will get. First IP is 128.0.0. This we call it as a network ID always. What will be the next IP address?
128.2.0.1.
Yes, very good. 2.0.1. Then it will be 128.2.0.2. Whenever this last octet comes to 255, 128.2.0.255, then you will write 128.2.1.0. Then whenever this becomes 1.255, then you will write 2.0. Okay. Now, what happens whenever this will become 128.2.255.255? Can I make it 128.2.3?
No.
No, because always the network portion will be same. If it is starting with if they belong to same network means the network portions must be same. If I write 3 means they belong to a different network. So this will be the end point. This will be known as the broadcast ID. So leaving network ID and broadcast ID, whatever the remaining IPs you have, those are known as the valid IPs. How many valid IPs we will get? The formula is 2 power host bits minus 2. This is how many host bits are there? 8 plus 8, 16. 2 power 16 minus 2, it will be 65,534 IPs. If you are comparing with class A, are you getting more IPs or less IPs?
Less IPs.
Less IPs. Why you are getting less? Because you have less number of hosts. You have more number of networks. Okay. So because they have developed this for the medium range, they are giving with the 2 networks. So you are getting 65,000 IPs. Okay. Class A, it was 16 millions because only one network network portion.
Yeah.
So any doubts here in this slide?
As of now, no, sir. I'll take screenshot, sir.
Okay, take the screenshot. So if you have any doubts, ask me.
Yes, sir.
So till now everything is clear. Any doubts?
Oh, no, sir.
Now let's think about the class C. Let's see how many addresses you will get in the class C.
Yeah.
Class C range 192 to 223. Okay. In class C you have 3 network octets and 1 host octet. It means you will get many networks, but every network will get less IPs. So first network will be 192.0.0. The next network will be the 192.0.1.0. The next network will be 0.2.0. Whenever this becomes 255, this will be changed. Whenever this becomes 255, this will be changed. So at the end you will get 223.255.255.0. You will get millions of networks. But take any network, for example, one of the network is 192.0.10.50.0, for example. 192.0.50.0, one of the network. Then class C you will have only 3, you will have 3 network octets and only 1 host octet. So the first network, always first IP will be the network ID. Then you will get a very less valid IPs because this is class C, 0, 1, 2, 3 up to 255. That's it. This network portion remains the same as usual because network octet will never change. Last IP is broadcast ID. In between the network ID and the broadcast IP, you will get only 254 valid IPs. Okay.
Yeah.
So you will get many networks in class C, but take any network, you will have only 254 IPs. Okay. So copy this one also.
Yes, sir.
Hello, yes.
Yes, sir, I'm able to hear. Hello? Hello?
Hey, Sandeep, just wait
Sir?
1 minute. I'm on call, okay?
Okay, sir.
Hello. Okay.
Yeah, please.
Okay, this one copied.
Yeah,
Okay.
done.
Go to the next one. Now, I have an IP address 192.168.1.57. Okay. What will be the network ID of this address?
57.
Network, this is the address. Okay. You need to find the network ID. That is the first address.
Yeah.
This is from which class?
This is from C.
Class C. How many network octets?
3.
3 network octets and one
1.
host octet. So if you want to know the network ID, don't do anything to the network portion. Let it be 192.168.1 only. Make the host portion to 0. That will be your network ID. Okay. If you want to know the broadcast ID, network remains the same, but the last last octet will be 255. It will become broadcast ID.
Yeah.
So host portion to zeros, all 8 zeros will give the network ID. Okay. Host portion all ones, complete octet 1, that is a 255, it will give the broadcast ID. Okay. Suppose if I am having an address 182.187.111.57, what will be the network ID and the broadcast ID? This is from which class?
So the network ID would be 0 and broadcast ID would be 225.
What, give me the complete network ID will be what?
Network ID would be
182 dot.
187 dot
Okay. Then
1 1 1 triple dot 0.
This is from which class?
This is from C.
182.
Yeah.
Class
No,
A,
no, 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 no. This is from
class
uh,
B.
B class. That's right.
Yes. So class A range is 0 to 127. Class B is 128 to 191. So this V is from class B. So the network portion remains same. Host will be changed to take the network ID, and the network remains same, and host all the bits will be changed to 1. Then you will get the broadcast ID. Okay. You need to know from which class these addresses are. Any doubt?
Yes, sir.
So
No, sir.
can you do for this one? For example, I'm having the address like 177.160.180.200. Give me the network ID for this one and broadcast ID.
This is belongs to B class, sir.
Okay, B means two networks,
And
two
two hosts.
hosts. So network portion remains the same.
And
Okay,
dot zero.
and broadcast ID
177
means
dot 160
5.
dot 225 dot 225 broadcast.
255, not 25. Okay. Any doubts till here?
No, sir. Here.
Okay, just check with these things. 5 minutes we'll have break.
Yes,
Then
sir.
we'll continue with some subnet mask, those things. Okay.
Yes, sir.
Hello? Hello?
Yeah, yes, sir.
Okay, fine. So let's start. Now, just let's have some more things like I have an IP address 192.168.77.60 and one more address 192.168.78.61. I want to know whether these two IPs belong to the same network or different network.
This belongs to different networks.
How can you say?
The third network is 77
Yes.
and 78.
So this is from class C. Class C will
Yeah.
have three network octets and one host octet. So if three octets matches, then they belong to the same network. Here they are not matching. It means they belong to the different network. Okay. I may be disconnected for a moment. Okay.
Okay, okay,
Okay.
sir.
If it is disconnected, don't worry. Okay. So this
Yes,
is
sir.
this is about the whether you are in the same network or different. For example, I am having one more address 172.16.50.7 and 172.16.50.8. They belong to the same network or different network?
This belongs to class B, sir, and same network.
Same network. Okay, two octets matches, same network. They don't match, different networks. Okay,
Yes, sir.
clear this one?
Yes, sir.
Okay, but now the important thing is yesterday we have talked about the switch. Switch is a device which makes the communication between the same network. So imagine I have a computer here, two computers here. One computer IP is 192.168.1.2. Okay, 1.10. Okay, and imagine this switch is connected to a router also. Somewhere in the internet, one more person is there whose IP is 200.1.1.5. Okay. Now, from this PC, I gave the command ping. No, let's change this IP. I will give the IP 192.168.50.70. I gave the command ping 192.168.50.70. What is ping? You know any idea?
It's just like calling that, whether it is on the,
Ping means
whether,
checking the communication, whether you are able to reach the destination or not. Okay. Ping followed by the IP. So you are telling the device, check the connectivity, whether I am able to reach the destination or not. So whenever you want to check whether you are able to reach any destination or not, you will use the command ping. Okay.
yes, sir.
So now I am asking my computer, the PC1, PC1 kindly check the communication whether we are able to communicate with the 50.70 or not. Okay. So now you are seeing the topology, you are aware that destination is in the different network, it is in a different place. Okay. But how the PC will understand that this device is not on the same switch, it is on the different switch? How it will come to know?
Packet loss, through packet loss.
No, that packet loss information is for us. Before it says us that they are unable to reach, he has to identify, no? Okay. So see here, listen carefully these things. The job of the switch is to make communication in the same network. Job of the router is to make communication between the multiple different networks. Okay. So whenever you are giving a command on your computer, you are saying to your computer, go and check the connectivity with destination. The first thing the job of your computer is to identify whether the destination IP belongs to same network or different. Because if it belongs to the same network, your PC will ask the switch to make communication and switch will make communication. If the PC knows it is in the different network, it has to forward to the router. So the decision must be taken by your PC that whether the request should be forwarded to switch or the router. For this decision can be taken once the PC comes to know that destination is in the same network or different network. You got my point?
Correct, sir. Yes.
Yeah. So the first job of the PC is to find destination is in the same network or different. If it is in the same network, it will ask the switch to make communication. If it is in a different network, it will ask the router, it will forward the packet to the router to make communication. For that, it has to identify whether it is in the same network or different. So now the question is, as you are aware of the network bits and host bits, now you can say 50.70 and 1.2 are in a different network. But how the PC will come to know, how it is going to identify, how the PC will calculate that 192.168.50 is not in my network? What it will do? It cannot directly, it cannot do anything, okay? Because even if I ask you that 192.168 1.2 and 192.168 50.7 50.70, are they in the same network or different? You will say different. How? You will check the three octets. Three octets are not matching, then you will say different. Yes, correct?
Yes, sir.
You are saying this because you have just now learned the class A, one network, three hosts, class C, three networks, one host. You have learned this thing. That's why you are able to answer this one. But what about the PC? PC never came to the CCNA class. So in case of PC, whenever you are giving the IP address, what you will do? First, you will configure the IP address. Then what you will configure? Subnet mask. You will write something like 255.255.255.0. Then you will write this interface IP. For example, on the router, the IP is 192.168.1.1. Then you will write the IP. So why I am writing this information? I am writing this information to tell my PC the first octet is network octet, the second octet is network octet, third is also network octet. Then the PC will check, okay, three octets are network octet, destination IP, three octets are matching or not. No, it is not matching. Then it will make a decision, okay, this packet, this information must be forwarded to the router because the destination is in the different network. When can it identify all these things? Whenever I write this information. If I don't write this information, PC will never take this IP. It will say IP information is not correct, invalid IP, because without this thing PC cannot do anything. So what we call this one? Subnet mask. Have you heard any time about this word subnet mask?
Yes, sir.
So subnet mask is used to differentiate the network bits and host bits of an address, by which only the devices will identify whether the destination is in the same network or different. So whenever you are assigning a IP on a computer or a mobile or a laptop or anywhere on a router, wherever you are assigning a IP, you must assign the subnet mask also. If you don't assign the subnet mask, it is like meaningless information. So device will never accept that. They will say invalid IP. IP information is not complete. Okay. So without subnet mask, everything is a problem. That's the same thing here. Subnet mask differentiates the network bit and the host bits. Network bits are identified by writing 1. Host bits are identified by writing 0. Okay. So class A, 1 network octet and 3 host octets. So wherever the network octet is 1, I will write in the subnet mask 1 time 255 because all 8 bits are turned on. If you turn on all the 8 bits, the value will be 255. Class B 2 network octets, that's why 2 times 255. Class C 3 network octets, that's why 3 times 255. Okay, this is subnet mask, one way of writing the subnet mask. The same thing you can write in the other method. Instead of writing 25500, you can even mention /8. /8 means 8 bits are the network bits because in a octet 8 bits will be there. Okay, so 8 bits. Class B 2 times networks, 2 network octets, 8 plus 8 16. Okay, you can write like this on /60. So if I am writing an address 192.168.1.0 with subnet mask 255.255.255.0, or if I write this address 192.168.1.0 with subnet mask 24, both meaning is same. There is no difference. Here I am using dash slash notation, CIDR we call. Here I am directly writing the decimal format. Write any method, not an issue. This one is
Okay.
take the snapshot of this one also.
Yes, sir. Yes, sir.
Okay. So now what we have seen till at the end, we totally we have seen these things. Class A will contain the what is the range of class A we have seen, the range of class B, class C. Class A you will get 16 million IPs, and we have seen about the subnet mask. Class A subnet mask is 25500, and class B is 255.255.00. In the class C it is 3 times 255. Okay.
Yes, sir.
So now if I am having a requirement of 50 IPs in my network, I am having 50 computers. I want to have 50 IP addresses. From which class you will give me the address?
From class C.
Class A, because it's less. If I am having a requirement of 1000 IP addresses,
I'll go to class B.
leave. If I am having a requirement of 1 million,
Yes, sir.
class A. But if you give me for 50 IPs class C, you are giving me 254 IPs. Means I need 50, but you are giving 250. So how many IPs extra you are giving? 204. Can I use them? No, I don't have any device. Can I sell it out to others? No, you cannot. Means what it is happening? Wastage. Yes or no? Okay. We are
Yes,
wasting
sir.
the IPs. I am asking 1000 IPs. You are giving me class B. You are giving me 16,000 IPs. Means almost 65,000 IPs. Means almost 64,000 IPs are wastage. I am asking 1 million. You are giving me 16 million. Means remaining 15 million IPs are wasted. So do you want to waste the IPs?
No, no.
So we want to save the IPs. For the saving the IPs, we will use a concept known as subnetting. Tomorrow we'll discuss about the subnetting. Okay. Right. So see till here whatever we have learned, check all these things. Okay. Then tomorrow at what time